Okay, the next step in machine setup is going to be setting up our fixture offsets. So just like the tool offsets, we'll come back to the screen and we'll cycle through until we get to our setup function. Number one, I'm going to hit that, and this time instead of setting up the tool, I want to go in and set up my fixture. So I'll press 2. We're going to do the read from jog option, meaning we're going to jog in position and use an edge finder to locate our part from. So option 2 there. And then this drops us into the fixture offset setting routine. This is real nice because basically all we have to do is just step through the numbers to get our fixture offsets set up. First thing is, which offset number do we want to actually set up or install on the machine? So to tell it that, we'll do option number 1. And we have the option of doing up to 48 different fixture offsets. The first common 6 are identified right here for you, and the reminders of the associated G codes, G54 through G59, that are associated with those fixture offsets, that being 1 through 6. So for our particular case today, why don't we just choose fixture offset number 1. So I'll press number 1, hit enter. And now it's going to ask me for a locator diameter. So what it's essentially saying is if I'm using an edge finder to come off and touch off the edge of my part, I need to know what the diameter of that edge finder is. And in our case, our edge finder is already installed into the spindle. We put that in tool 3, and it's a 1/2 inch diameter. So I'll put in 0.5 for my edge finder diameter and hit enter. What RPM would I like to spin my edge finder at when I'm going to use it? And 1200 RPM is usually a good number for me, so we'll use 1200. It drops me again into auto mode, and essentially what it's going to do when I press start is set the spindle speed to 1200 RPM. So S, 1200 right there. And that writes the spindle speed to the machine controller. So if I was to turn on the spindle now by pressing shift spindle on, like I just did, spindle's on and now it's spinning at 1200 RPM. Okay, I'll shut that off for a second. And the next step we want to do is go in and actually use our edge finder to find the edges of our part. So we have a piece of stock clamped in our vise already, and we want to locate the X location and the Y location, and of course the Z location of this stock. Again, this should be in relation to our program. So we're making the assumption that the NC code was written such that this back left corner is the origin of our program. So we're going to be setting things up so that that corner is going to be our origin. To do that, I need to go into option 2, which is jog to locate. Essentially, I'm going to go into jog mode. So I'll press 2. And the controller just tells me to hit the jog key to drop us into jog mode. And now we're in jog mode. And I can position the edge finder to come over and touch those faces. So let's touch the X face first. So we'll jog the Y axis, and we're already in Y. I'll grab the MPG wheel. I need to move the spindle back. And we'll change it to Z, and I'll use continuous jog function here. Just bring it down a little bit. Looks like I went a little too far in Y. Whoops. And then let's go in X. Okay, so it's always a good idea to position your edge finder close to the point on the surface that's going to represent the origin of your part. So since I want that corner to be the origin, I want my edge finder to be up closer to that edge. That way, if there's any deviation of this surface from parallel, that's not throwing off my setup. So let's do that. I'm going to move that up close to the edge. Down in Z, offset my edge finder, I'll turn on my spindle. Again, shift, spindle on. Now the spindle is going to come on. And then we can just step in similar to the way we did on with the tools, with the 1, 2, 3 block. Progressively step in until our edge finder touches. So we'll go to X motion. We're going to be moving the spindle positive. I'm in my largest increment, and I'm just watching until the edge finder jumps out, which it just did. So now I'll back it off a couple of clicks. I usually like to flip it again so that it's running closer. And now I'm going to change my increment from the 10,000th increment to the 1,000th increment, and then step jog it in. So X positive, and just bump the jog button. Again, I'm bumping by 1 thou at a time, and I need to be watching my edge finder for the point where it bumps out. Right there. Bumps out. So now we know we have located the edge of our part, and we can store that location. So to do that, I'm going to press manual to get out of jog mode. Come back into our main screen here and go into option 3 for store location. Here we go, 3. And it's asking me which location I want to store. We just did X, so I'm going to tell it X by pressing the X key. And then you'll notice that it writes, oh wait, sorry, it asking us now which side of our edge finder, which side of the surface is our edge finder on. So here's our surface, right? Positive X direction is to the right of the machine. We got our right hand rule that we can use to help us identify axis direction. So if I line my index fingers up with the Z axis, this is going to be positive Z, positive X, positive Y. So we are on the negative side. This would be positive side. This is the negative side of that surface. We're on the negative side. So I'm going to do minus for negative side. Hit minus. Now, right here in the fixture offset value for X, that has been rewritten with our current location plus our locator compensation. So it's taken this value, added that value, and written that right there. And that is the value that's stored in our fixture offset registry. Okay, once we've got X done, now we repeat that process for Y. So I'll exit out of this, go back into jog mode, and then we can move the edge finder over to do the Y side. Again, bump it, bring it back, get it flicking real good, and then step it back until it bumps out. There we go. So we'll store that location, press manual, store location, and then Y. And then the same question. This time we're going to be on the positive side of that surface, so we want to push the plus key to tell that we're on the positive side. And it'll write this value compensated for our diameter and puts it in right there. Okay, so let's shut the spindle off at that point. So now we have X and Y stored. The last component would be our Z value for our fixture offset. And let's just take a second to kind of describe conceptually what we're doing there. Our fixture offset values for Z essentially need to represent the distance from the reference point or the reference datum that we use to measure our tool length offsets from up to the top of our part. So we did our tool length offsets all from the table. We utilized this as our reference surface. Now we need to figure out essentially what is the distance from this up to the top of our part. And that's the value that we want to be represented in our fixture offset value for Z. Now there's a variety of ways that one can do that. And I'm going to show you one method that essentially allows you to use the machine to measure this distance. And you just do a little bit of math using the jog values that you'll pick up off of jog mode and your tool length offset values in order to do that. So the first thing I need to do is install a tool in the spindle that I've already done a tool length offset for, or already touched off. So in order to do that, I'm going to need to exit out of this routine. So I'll hit any key to exit and then press 9 to come out of here. Then I can go into MDI mode. I'm gonna send it home first. So let's go 4 home. Get everything reset to the home position. I'm done with the edge finder at this point as well, so I'm going to go ahead and take the edge finder out. Again, taking a tool out of the spindle is the same as putting one in. We want to make sure that you're grabbing it in the safe zone, so down here below the double B flange. So I'm going to grab it here, push and hold the in and out, tool in and out key on the controller, take it out, and then release. And then that's how the tool comes out. So we already touched off tools 1 and 2 earlier. I'm going to go ahead and grab tool 1 in the spindle again, and we'll use that tool for doing our measurements off of our stock workpiece to establish our fixture offset Z. So we'll go into MDI mode, so I can execute a tool change there. Press manual until I get in there. Tool change command is M6, followed by the tool number, so T1. We'll hit enter. Again, it's going to ask for acknowledgement first time I entered in a first line of code, and I'll hit start to let it execute the tool change. All right, there we go. So now we've got the tool loaded into the spindle, and I just need to jog over and touch off the part, or touch that tool off on the top of my part to give me a value. So I'm going to take advantage of one other thing at this point. I'm still in MDI mode right now. So this is the screen where I can enter G-code directly. But I can also go into jog mode right now if I wanted to and jog the machine around, exit out, and I'd still be in MDI mode. So it allows you to kind of use jog mode in conjunction with G-code if you need to for various setup stuff. I'm just going to press jog, and it drops me right into jog mode, and I'm going to position the tool over my part. So we'll come over in X. Move it up to a faster increment. All right, always slow down in Z. Then the process is essentially the same. I've got my 1, 2, 3 block that I'm going to use as a gauge, so I can use this to touch off of. Set that on top of my stock. Come down in Z. And then go through the touch off routine. So again, right now I can slide the block underneath it. So I'll come back down 1 increment, check to make sure that I can't slide, go from the 10th hour increment to the 1th hour increment, and then I want to step up, so I'll do plus and then incremental jog by pushing the jog key once, bump, and just bump that until I can slide underneath it, which I can there, and then if need be, we can go to the smallest increment and repeat the process. One little side note about that: when you are touching off real tools, occasionally you'll find a tool where you can slide the block maybe under 1 flute or maybe 2, but not all the way under. Well, what that means is that particular tool is not, you know, perfectly parallel, or in our case, it may be that this surface is not perfectly parallel. But you got something hanging down just a little tiny bit lower. Which means, you know, you want to basically find the lowest spot of your tool. So you want to be able to adjust those things until you get the block to slide all the way under, and that will ensure that you're not, you know, undercutting anything in your programs. You can always move things down, but once you've removed material, it's hard to put it back on there. Okay, so I've got it, so I can just slide it all the way underneath here. Now at this point, I need to take note of the values that I've got. So this value right here, that's the distance that I've moved down from the origin of my home position on the machine. And we need this value plus this value or minus this value, essentially compensated for the height of our 1 through 3 block. And then we're going to use those values in conjunction with the tool length offset, which again is the distance from my home position origin all the way down to the table, to calculate the distance from the table up to this. So to do that, I'm going to exit out of jog mode, just press manual. I don't need to be in MDI mode anymore, so I can hit manual to bail out of this. I'm going to cycle back through until I get to my setup menu here and go back into my fixture offset setup menu, so option 2. Again, we're going to go read from jog. I'm just taking us back to where we were at. And now I want to do store location. I want to make sure that I'm doing it for the fixture offset that I was doing previously. So by default, it sets to fixture offset number 1, which is the one that we were using. If we had selected a different fixture offset, 2, 3, or 4, I need to go back in here and select that one in option 1 before I stored the location. But since fixture offset 1 is currently active, I can go directly into store location, so 3, and now I can store the Z value, which is Z here. And there we go. We took our value that we came down to, we touched off to in jog mode, and that's been written into our fixture offset table. All right, now the next step is to compensate for our 3 inches on our gauge block. So we need to go essentially add that additional distance to this value in our fixture offset table. And I can show you a simple way to do that. So I'll get out of this routine by pressing exit and getting out 9 to exit here. And what I'm doing is going to go into the offset tables directly and then modify the values in our offset tables in order to make that compensation. So in our menu system, we have got one menu for offsets, and it's number 6 here. So I'll press number 6 to take me in there. The first offset table that we see is our tool length offset table. So these are all the tool numbers that the machine can hold. So there's up to 24 in this particular machine. We've set up tool number 1 and tool number 2. There are other values that are in this table, but that's from previous operator setups. So we didn't do those in this particular routine. They just hang around until you either delete them or overwrite them by setting up another tool. If we press the space bar, it'll take me to the next table, which is our fixture offset table. And same thing again, we were working on fixture offset number 1, so hopefully these values look familiar. There's our minus 10.2969, and then other values from previous operators and their setups. So I want to modify this value right now to compensate for that additional 3 inches. And I can do that just by using our menu option number 2, modify. So 2. And it's asking me which offset number I want to work on. I'm going to work on number 1, so I'm going to press 1 here. I'm not going to change X, so I'll keep the default value, press enter. Same for Y. Z, I want to subtract 3 more inches, and that's for our 1, 2, 3 block gauge height. 1, 2, 3 inches right there. Hit enter. We don't have an A axis or a B axis, and then essentially gives you an acknowledgement screen or a chance to ensure that you did your operation right. That's what it was. This is what it's going to be when you accept it. If you like that, you press 1 to accept it. Modifies the table, and now we have updated the fixture offset table for our gauge block length. Okay, the final step then is to take that value and essentially add to it our total tool length offset. So one last time, we've just stored the value that the head will have to move down to go from the Z home position 0 down to the top of our part. So that would be the distance that this head has to move to put this tool right here. Our tool offset length represents the value that the head would have to go to move from the Z home origin to put the tool down to the table. So basically we have head down to the table, or origin down to the table, and then origin down to the top of this part. If I do the difference of those two, it gives me the distance from the table to the top of the part, which I want in the fixture offset table value. So I can just press the space bar, cycle through here. We have tool 1 in the spindle. I can verify that by reading the status line right here. It says tool equals 1. It tells me tool's 1 in the spindle. So I know that my tool length that I'm using is minus 19.6959 inches. So 19.6959. Come back to the fixture offset table, and I'll do a modified value again. Number 2, we're going to work on number 1. We're not changing X or Y, but in Z, I'm going to add 19.6959, our tool length offset right there. So I'm adding or subtracting a negative value. It's both of the same things. Press enter. We don't have an A or a B. You can check and look and see what our value is. And so we come up with 6.3999. I'll accept that. And that's what our fixture offset Z value comes up to. Now, the check here that you want to make sure that you're doing, this is a reality check. This value should physically represent the distance from this down to this, or from the table up to that. So certainly valid to grab a steel rule and stick it up there, and even a pair of calipers, and do a quick gut check to ensure that you didn't mess up the math there and that you got a correct value for your fixture offset setting in Z. Once you've got that, you've essentially set your fixture offsets. So what we'll want to do now is good practice is to send the machine to the home position. So this time I'll cycle through the menus and use the home axis function to send it to the home position. So 4 and option 1 to return to home, and start it. And there we go. Fixture offsets are complete.